Okay.
Yeah, fine. Shall we begin? Here we have good number of participants here. Fine. Okay. So what we are discussing today? What topic we are discussing? So what we are discussing here is random process we are discussing, right? Module 3. In that first one we have discussed ensemble we have discussed. So we are discussing on random process. Okay. That first one we are discussing ensemble. This already we discussed. Okay. Yes. So next one is we are discussing on PDF. So means how the probability density function of this is going to be. Okay. So can anyone quickly say me what is meant by random process? What do you mean by a random process? Quickly. Any one of you?
Collection of set of functions.
A collection of set of functions. Okay. Yeah. Find anything else? Any one of you further? Random process. See, first thing, any when you are trying to look at right any module here, so all the definitions you need to know with the basic examples. So each one of them, one definition you need to know, and you need to know the basic what definitions with examples. Okay. So here you need to know what is meant by a random process and what is the example of that, how to understand, how to make someone understand what is meant by a random process. Any one of you, please go through fast and let me know what is meant by a random process. So this all prerequisites, if you are not satisfying your prerequisites, then it will be difficult for you.
In a random process, the result is uncertainistic, sir.
Okay, the result is uncertainistic, fine, yeah. Then further. So that's what, see, what I mean to say here is, anything when you see here in this module now, anything when you see in this module here, three things you keep in your mind. The first thing is what you should know is, you should know the definition of it. You should know the definition of it. And after that, what you should know? What you need to know? Definition you need to know, and second you should know is, along with that you should know some example for this, right? And third thing what you should know is, you should know how to explain this concept. So definition, example and explanation. So these three if you know, and automatically you'll get the confidence in it. So first thing you should know, I'm asking you, is what is meant by a random process. You should know a definition and you should know the example. Similarly, along with random process, you should know about the ensemble. Okay, yeah. So we'll begin with next one. So PDF. So what is ensemble? Ensemble is a collection of possible sample functions. Whatever sample functions we have, right? All the collection of that is what? All the sample functions is called as what? Ensemble. Okay. Now we'll see what is PDF. We know, right? What is PDF? PDF means what? PDF it is your probability. It is what? Probability. So one second. Yeah, let us begin with today's class, PDF part. So PDF is what? Is the probability density function. Now probability density function, we need to look at that for the random process. Okay, please stay focused. So this is for probability. You all know that, then we go for the next one. Probability density function. Okay, yeah. So now we need to see the PDF for different things. So we need to see the PDF for different things. The first one we are going to see here is the PDF for single random process. For a single random process. So what is the single random process? As we have seen, what is random process? Random process is given by x of t. What is x and what is t? This x is your what? What is this t? What is this t? X is random variable. What is t? Huh? Independent variable. Independent variable, right? It's a random variable. It is independent variable. Now single we are asking. So t is single or double or multiple or two? Only one, right? So when you are representing only one entity, it is only one entity, right? Single. So single random process. So single random process is x of t, we know. Now what is the PDF of it? See, let us say if you take x is a random variable. So this is random variable. For random variable of x, what we wrote, f of, how we wrote that? Fx of x we wrote. Correct? Now, instead of this x place, we have something called what? F x of t we have. So is this your PDF for this random process? Are understanding it? So for this corresponding thing, the single PDF for a single random variable, PDF for a single random variable x of t, we can represent instead of, okay, we can represent like this. So instead of time, we are removing this time, and we can be, it can be anything, right? It can be anything. It's not only time. Okay. So it can be called as, let us say, x. So with that mind, we are trying to write always PDF will be smallest, small x of t, small x of t of x. So this is going to be always greater than or equals to 0. So for all the limits of minus infinite to the value less than its x value less than infinite. So what is the meaning of this one? So the PDF of a single random variable is what? Okay, is what? It should be greater than or equals to 0. The value of this is going to be always greater than or equals to 0 for the value, so from minus infinite to plus infinite. So this is for single random variable. Now when you look at the second one, the PDF condition for second one is what? Can you guess what is second one can be? Second one, what it can be? PDF for two random process. So we can see the PDF for two random process. What is this two random process? So two variables we should have. Okay, two variables we should have. So what are the two variables we can take? So which means this is the other form of this is also called as what? This is also called as, what can we call this as? This is the bivariate PDF. This is the bivariate PDF. Okay. Now let us understand here, like let us say x of t1. X of t1 is one of the random process, and sorry, and x of t2, this is one corresponding random process. Okay, and here this other random process. So two random process we have. We have at time t1 and we have at time t2. Okay, so let them be two random process. These two are what? These two are two random processes. Okay, then if you want to find out this one, if you want to find out this bivariate PDF for any pair of this, we can find out at time t1 and at time t2. At this only we can able to find. Then how to represent this one, the PDF of this? To represent this, f is a PDF if you represent. So this also can be x of t1 and x of t2 at any given point. Let us say these given points can be x1 and x2. So there are two different points. So this also correspondingly will be equals to 0, but the condition is for the value of x1, less than infinity, and for the value of x2 less than infinity. So for this condition only we can have the PDFs of the two random process. So we are trying to represent the terminology, how to represent if it is two random variable, how to represent if it is single random variable, all that. Okay, is this clear? Second statement, how to represent the PDF for two random processes. Let us say first process can be x1 of t, second process can be x2 of x of t2. Let us say x1, x of t1 and x of t2. For that corresponding events, it can occur at x1. Let us say it can occur at x1. It can occur at event x2. For the corresponding x of t1 can occur at x1 and t2 can occur at x2. So this way we can able to write the PDF for the two random process. Okay. Now, if you want to write bivariate PDF of two random process, so if you have seen there, PDF of two random process we have seen. Now, same thing. If you want to write the same thing with two different variables, let us say same as second one, but only thing is here is two different it is. We are trying to take x of t and y of t. Whereas this one, if you look at this, one, second one, we have, let us say, a time graph here. So this is a time graph. So I have taken one point here. this can be x1. I have taken at second point, this can be x2, which means I want to find out at point 1 and point 2. Okay, but whereas this one, when I am talking at this one, so this is the first one where I am taking one point here as x1, and I'll take second one somewhere here like this. So this some other graph, some other variable, and this also I'm going to take at y1 in this way. Okay, so is it clear? In this way we are trying to find out for two different things. So this is this and this separate things we are trying to find. Okay, so for this one, if you want to write the corresponding PDF of this, the PDF of this one, if you want to write, how to write based on this, you can check it out and tell me how to write. Let us say this can be for reference only x, only one variable is there, I'll just use as x, and only one variable is there, I'll use just as y. I'll use as x and I'll use as y. Then how to write this one for this? Fx of t1 into what? Into what shall I write now here? What to write? Shall I write x or y? Y of t2. Okay, y of t2, because this time can be what we don't know. These two both times cannot be same. We don't know. This time here and this time here, it can be 1 here, it can be 4 here, because the scale what we use may be different. Okay, both can be different. So that's why we wrote x of t1 and y of t2. For the corresponding x and for the corresponding y, it should be always greater than equals to 0. Then for what is the condition for this? The condition of x will be less than infinity, and the condition of y is going to be less than infinity. So this is what the condition for the third one. What is first one? Quickly you look at this PDFs. First one is very simple. First one is this. First one is fx of t for corresponding x will be equals to less than equals to 0. That's the first one. What about second one? Second one is this. Okay, and this corresponding thing is the third one. Right? And can we find out what can be fourth one? How can we increase the complexity of this fourth? How to write for fourth one? So we have seen 1, we have seen 2. 2 again, 2 are same and 2 are different. We have seen like this. Now we can able to see something called multivariate. Something called multivariate density function. Multivariate density function. Multivariate density function. Okay, so that can be equals to what? How can we give that? How can we give this expression for this? Can you think? Okay, I'll just give the clues here. F of x of t1, okay, x of t2, and so on up to x of tn. Now what to write here? Can you tell me? Yeah, tell me. Hello.
Yes, sir.
Yeah, can you try this? What to write there? What to write? What to write last here? X what? X suffix. See, it's very simple.
N,
We are
sir.
trying, yeah, n. So it's very simple. We are trying to use only, keep one thing in your mind. We are trying to use only x of t1. Then only x1 will come. We are trying to use x of t2 also. Then x2 also will come. Like this, this is the extension part. This is the extension part what we have written. Similar, this will extend. Is it correct? You have to understand this, what we wrote here. And now you can tell me what is that here. What we'll get here, you tell me. For the multiple random variables. Tell me. Already I wrote here. If you understood that, you tell me what is that here. Quickly. What is that here and what is this here? X of what? You should tell me. Is this correct or wrong? I say it's wrong. Where is the mistake? Can you tell me where is the mistake? Hello? Can you look at this and say me where is the mistake? Here is the mistake or here is the mistake? I will tell you here is the mistake. How to correct this mistake? What to write there? We are writing x1, x2.
Xn, sir.
Exactly. Here we should not write like this, right? So we should
Xn,
write
sir.
what? Xn we should write. Exactly. Yeah. So it will be equals to xn. Now I'll give some more complexity of this. Xn is perfectly fine. Now what are the limits can we write for this? What are the limits can we write for this? What are the limits can we write for this? This is minus infinity to x1, x2 and so on, xn less than infinity. Before we wrote only x1, right? Now we have to write all the including all of them. So it will be to infinity. So like this, all the values of this will be between minus infinity and plus infinity. Yeah. Now we are going to the real challenge. If you can tell this one, then I can able to confidently say that you can write any of this. So fifth one, what we are writing, fifth one. Fifth one is what? For joint random process. Joint random process. Joint random process for x of t and y of t. Joint random process x of t and y of t. You want to find out now multivariate PDFs for this. You want to find out multivariate PDFs of order n. If you want to find this, and how to write this expression for this. F of what to write? X of t1, then x of t2 and so on, what? X of tn. Along with this, what is one more? Y. Correct. Y of t1, because t1 will be same here and here, we'll use t1 dash. Then y of t2 dash and so on up to what? Up to y of tn dash. This is the denominator part, below part. Here what we should write now next? Here what to write? x1, x2 up to xn. Along with that y1 dash, y2 dash and so on up to yn dash. So this value will be also equals to greater than 0. Now how to write the limits now for this? This will not be there. This much complex things are not there. Just we are trying to look at this in general. How to write the limits for this now? The limits will be from minus infinity to plus infinity. This is same. This is less than here and this also is less than. So what to write in between these two? Okay, or else we'll write in two lines, right? x1, comma x2 comma, right, x3 and so on up to xn should be less than that limits. And one more thing, minus infinity less than, right, y1 dash, y2 dash and y3 dash and so on up to yn dash will be less than infinity. Okay, it looks difficult actually. When you look at that, it becomes very simple. Is this clear to you how to write the PDFs for the multivariable expressions? Hello? Yes or no? Now let us see an example. Yeah, Bharat, tell me. Sorry. Yeah, let us see an example now. Take this problem and try to solve it. Example on this PDFs. So we have a multivariate PDF. We have what? We have a multivariate PDF. So multivariate means what, you know? Multivariate PDF. I'll tell you of order 3. Of order 3 is given. How they are given the expression? F of x of t1, x of t2 and x of t3. Okay, and this corresponding thing is x1 comma x2 comma x3. So this is what they are given. What they are given, it is greater than equals to 0. It's all question they are given. And the limits for this is what? Minus infinity less than x1 comma x2 comma x3. So this is the limits what they are given. Now what you need to do here? So this is a question what they gave. Now what we need to do is find first one. Find the PDF of fx of t1 for the corresponding x. So this one you have to find. How to find this? How to find this? Any one of you? The first question. Second question for this, you need to find a multivariate CDF. You need to find the multivariate CDF for corresponding, same thing. A CDF means capital will have x of t1, x of what? t2, x of t3. Order 3, right? What will get? x1, x2, x3. So this one you have to find second one. And third one, what you have to do is you have to find the CDF of this one. So this is the question. It's very, very simple answer. Straight away we can do it if you know the concepts of this. First tell me how to do this first one. PDF of this. How to find this PDF of this. How to do that? For this is the corresponding function what they are given in the question, right? So this corresponding question, what you need to do is you need to apply double integral for that. You need to apply double integral for that because the limits are minus infinity to one second. Yeah, there is some malfunction here. Yeah. So you need to apply the double integral for this, and the limits for this is minus infinite and plus infinite here, and minus infinite and plus infinite here. And you need to Ashwita. Yeah. So yeah, if you see, if you want to find the corresponding PDF of that, it's very simple. What you need to do is you need to apply the limits for this, for integral to integral, minus integral to plus integral, and minus integral to plus integral for the corresponding thing, and you need to differentiate that with what? With the dx1, dx2 and dx3. So you need to do it with the dx1, dx2 and dx3. If you do the derivation of that and if you do the integral of that, I think one more integral you can have, because order 3 it is minus infinity to plus infinity. So this corresponding thing, it is for time t1, this is for time t2, this is for time t3, and you want to derive it for x1, x2 and x3. So three things, then you're going to get this fx of t1 at x. Okay, which means at one instance you'll get it, right? And what about next one, multivariate? If you want to do it, it's also very simple. If you want to do the CDF, it's very simple. Again, what you should do for second one, if you want to get the answer, you should again integrate with 3 times, because we have t1, t2 and t3, three things are there. You need to integrate minus infinity to take up the limit up to x1, and you can take minus infinity to limit x2, let us say, and minus infinity to the limit x3, you can take that corresponding point. And you need to, if you want to get the CDF, what you should do, you need to integrate the PDF. So PDF is what? Small f. Small f of x of t1 followed by what? X of t2 followed by x of t3. Along with this, you need to write this function x1, x2, x3, and you need to integrate that with respect to dx1, dx2 and dx3. Then you're going to get it. So this is the thing. So this complete thing is your PDF. Okay, when you integrate the PDF, you're going to get the CDF. You all know that. So PDF is given by small f and CDF is given by capital F. PDF is given by small f and CDF is given by capital F. Whenever you want to find this thumb rule, you should remember, whenever if you want to find the CDF of it, CDF is given by capital F of x, let us say. If you want to do this, you need to integrate small f of x. Okay, so this corresponding thing, if you want to do it like this, if it is like this, if you want to extend this of t1, if you still have something x of t2, you'll have x of t2. Okay, here instead of x and x1 and x2, you also will get x1 and x2. And here x of t3, order 3 will increase, order 3, here also x of t3. Here you have x3, here also you will get x3. Shall I tell you once again? Yeah, please listen carefully. Everyone please stay focused here now. Please stay focused. Wherever if you want to find the CDF, you apply this rule. See this very carefully, observe. CDF if you want to do, you need to integrate the PDF. Okay, so CDF is given by function f. Okay, and PDF is given by function small f. If you are trying to find fx of x, then it's going to be equals to integration of fx of x into dx. Okay, and now if you want to change this, if you want to extend this, let us say, okay, if you want to extend this, then what will happen, you please carefully watch. If you want to extend this, if you want to get for x of t1 of x1, if you want to find, then this also will be x of t1 of x1 into dx1. So this is what you're going to get. And now still if you want to extend further, if you want to extend this further, right, then what will happen? If you want to extend the second variable, if you want to extend this like this, x1, x of t1, x of t2 of x1 and x2, then this will become x of t2 and x1 and x2. x2 is you have something here, double integral you should take and integrate with the dx1 and dx2. Is this clear to you what we have to do? Yes or no? Okay, so that's what you need to do for the tell me.
Clear, sir.
Yeah, fine. So yeah, we'll go for the next one then, and finally the last one. So last one, if you are trying to do, I'll just tell you, you have to find the thing here. You want to find the CDF for this one, fx of t2 at corresponding x. You want to find anywhere, somewhere you want to find for fx of t2. So we know something here. We know that fxy of integrity comma y will be equals to fy of y. So we know this formulas before. Fxy of x comma infinity, then this is going to be fx of x. So what is the meaning of this one, you know? I'll just tell you with an example. Just listen carefully. Wherever you have something like this, something we have like this. Now, this x value is this side, let us say. X value is this side, or anywhere you can take. This is your y value. This is your y value. Now, x value is infinity, which means somewhere here it is, this side. Okay, and y value is somewhere here. Now, in this case, we no need to consider about x. Straight away, this corresponding thing we are going to get as fy of corresponding y. So this is the y value. This is the actual x point. Let us say this is the point x, and this is the corresponding x. Somewhere, anywhere in the line, you take a point that is x. That corresponding line is your capital X. Let us say, and something like this here. If you take this also, this is a capital Y, and any point you take on that, that is your small y. Okay, this is your small y. Now this x value is infinity. X value is infinity now in this case. Now you're going to get same as this. Similarly, for the graph, if you take like this, x value you have somewhere here, x value you have the x value, and this y value here, is infinity. Then this corresponding graph will be resembles like fx of x. This will resemble like fy of y. So this is the property of the CDF. Okay, with this property, what we are trying to write here, you just carefully watch. What we are trying to write here is we want to find what this one we want to find. If you want to find this one, that is going to be equals to fx of t1, and x of t2 and x of t3 we have. Okay, and you need to do it with what you have. Only t1, t2 only you have. There is no t1 and there is no t3. Then what to write now here? This value we don't know. This value is x2. This value we don't know. What to write here? This we will write infinity, and this will write infinity. So this is how we can find it. Am I clear to you what I am trying to say? Actually, so this functions, you see this one here carefully. If they are given you the functions, okay, fx of t1, x of t2, x of t3, and correspondingly x1, x2, x3, if they give you, then you can mention, replace the value here by x1, replace the value by x3, right? Now what they have did here, they don't have any value of this, this also they are not given, this also they are not given. So that becomes then what? It becomes fx of t2 at corresponding x value they gave. So that's the reason why we are trying to write in this manner. If you don't have the, if they're not giving you, it's an order of 3, but they gave only one order, remaining 2 orders they didn't give. In this case, you should be able to do in this manner. So this way you should do it. Okay, so that's the example what we have for the PDFs. Hope I am clear to you what is that happening here. It's an example. Anyway, I will share the notes to you. You can go through that and you can understand also. Yeah, so just we'll briefly begin one more concept we'll see. That's called, the next concept is what? Impedance. It's very small concept. Just will complete that. It will take hardly 5 minutes. Okay, sorry, independence. So this is the third concept here. First we have seen ensemble, and then we have seen PDF, and the PDF we have seen one example problem we have seen in that, and now we are going to see the next concept, independence. Okay, it's very simple concept. Just remember these points, you can understand that. If you have any two random variables, if you have any two random process, not variables, sorry, we have any two random process, okay, and we need to say that they are independent. Okay, what is independent? Let us say you have two friends are there, friend A and friend B. Friend A will wake up at 6 o'clock. Friend B also will wake up at 6 o'clock. They are friends, right? They'll wake up same time. So then they are not independent. friend A will wake up at 6 o'clock here, friend B will wake up at 8 o'clock, so then they are independent. There is no correlation between those two. Okay, something like that here. So thinking that in mind, let us look at that here. Now, if you want to find a PDF of that corresponding thing, fx of t1, okay, and x of t2, and corresponding to that x1 and x2. I told you already to you, so this place whatever we wrote here, this place whatever we wrote here, this is your random variable, and this place whatever we wrote here, this is your independent variable. Okay, now if you want to find out this one, what we are trying to find, they are independent to each other. If this random process x of t1 and x of t2 both are independent to each other, then what will happen here is we will get the expression, the PDF of the corresponding thing will come like this, will come as fx of t1 at corresponding x1 into fx of t2, okay, at corresponding x2, which means these two are independent. There is no relation between these two. So this independent and this independent, they will get the product of that. So that way we are going to tell that they are independent. So if this is matching, if these two multiply with each other, then it's your independent variable. Now if you want to do it for n variable, now I'll extend this. You watch carefully. If you want to extend this, what will happen here? In general, okay. In general, if you want to write this, if you want to write it for x of t1 and x of t2 and so on up to x of tn, if you want to write this like this, if you want to say they are independent, if you want to say that they are independent, then what to do here, how to extend this. So we have only 1 and 2. Now how I want you for writing for n, can you please tell me how to write it? We have 1 and 2, we wrote it. Now I extend it for this one, so which means this portion you should tag it off. Correct? How to write that now? F x of t1 and x of t2, extend this tag up to x of tn. Correspondingly, we wrote x1 comma x2 and we stopped. We'll extend this further up to xn. If you want to find this, that will be correspondingly equals to what? Previously we wrote this and left it off. Fx of t1 of x1 into fx of t2 of x2. We wrote this and left it off, correct? Now what to do further for this? Along with this, what to do? Extend this up to what? Fx of tn of xn. Is that clear to you? Okay, so this is what your independence it is. In the next class, we are going to see the fourth concept. So in this third module, fourth concept we have. What is that fourth concept? Is your expectations. You all know that what is expectations. So that we will see for random processes. We will see the expectations. So expectations means what way we are writing, right? U of x we wrote for single random variable, and we wrote, or else we wrote e of x we wrote for single random variable, and we wrote e of xy for multiple random variable. Now what to write now for this? It will become e of what? It will become x of t. So what is this we are trying to see? Okay, is that clear? So this is what we are going to see in the next class. So we'll see the expectations, and followed by expectations we'll see the concept of stationarity. Okay, all right. Any doubts here till so far? So please go through today please go through what is meant by PDF, how to understand that concept, and what is ensemble and what is random process. These three you go through, and next class we'll see expectations and stationarity. Okay, so we'll see that. So any doubts here so far, you please let me know, or else we can make him.
Thank you, sir.
Thank you all. Thank you.
Yeah, sir.
Thank you.
Thank you, sir.
Thank you. Thank you all.